Good afternoon, ladies and gentlemen. Welcome to the Big Innovation Pitch. My name's Ian Nicholson. I'm Director of Sequel and Infrastructure at BRE, and it's my pleasure and honour to be chairing the judging panel for this session. So, for those of you that aren't aware what the Big Innovation Pitch is, it's a partnership between BRE and FutureBuild at this year's exhibition. The objective is to unearth true innovation from across the built environment to provide solutions for the big sustainability challenges that the built environment is facing. Throughout the day, we've got 6 sessions, 6 different themes. This is the critical infrastructure theme. Some of you may well have been to some of the earlier themes this morning. And they're taking place around the different small theatres around the hall. So for critical infrastructure, the challenge is to identify innovation that will enable infrastructure to deliver on the grand challenges of delivering net zero carbon, enhancing natural capital, and becoming more resilient. So we've got 6 shortlisted innovators that you're going to hear from now in this session. It's going to be a bit of a Dragon Den style, and I say style because the one big omission is we haven't got great wads of cash to hand out, so apologies to those of you that are pitching if that's what you thought. But you've got a 5-minute pitch, and then 5 minutes where we as judges can ask you questions, and then after that the judges, we will deliberate for 10 minutes and we will announce a winner. That winner then goes on to participate and have the joy of pitching a second time tomorrow afternoon against the winners of all the other 5 themes to give an overall winner of the year. So that's the way it works. For those of you that are visiting again tomorrow, do come along at 4 o'clock tomorrow on the main stage. That's where the winning round will take place. So we'll move on. I will very quickly introduce my colleagues as judges. I have Professor Alan Simpson, who is Professor of Landscape Architecture and Urban Forestry at Leeds Beckett University. We have Ruth Calderwood, Air Quality Manager for the City of London, and Sue Illman, Managing Director of Illman Young Landscape Designers. So I thank you all for giving up your time to come and join us today. So without further ado, I'm going to hand over to the first of our organisations, Plant E.
Thank you very much. Welcome everyone. I'm Rolf Schulte, Commercial Manager from Plant E, a Dutch company. Plant E has developed a biotech product that helps to fight climate change by offering you a solution for your critical green and blue infrastructure. Imagine a product which harnesses the power of nature, literally. Wouldn't you like to reduce stormwater nuisance, reduce methane emission, and in the process improve the quality in your city by adding plants? And as extra, you also get some energy produced by those living plants. I'm sure you would. Well, our Plant E box can do that, but it can do more. Green the city with living plants, produce carbon negative electricity, reduce methane emission, store rainwater, increase biodiversity, and treatment of wastewater. We do all that and more with our Plant E box. And the great thing about our Plant E box is it can be placed above ground, below ground, and on multiple locations. I've showed you all the powers of our Plant E box, and I would now like to zoom in on the most amazing aspect of our Plant E box, the production of energy. How do we do it? You know photosynthesis, the plants use that for their growth. And in that process, the plant produces organic material. A part of that organic material, the plant excretes via the roots into the soil. In the soil live bacteria. Those bacteria use that waste material, organic material, and they produce electrons in the process. we have come up with an invention that harvests those electrons, and there you have our power source, a 100% green and environmental friendly energy source that is also carbon negative. It's an amazing product, and it can be used for powering lighting, for sensors. It can also be used in offices as inspiration, as design. It can be used on green roofs for water retention, cooling buildings, to increase biodiversity in cities. And the product can be used in parks and on roadsides. Water retention, living light experiences. It offers amazing opportunities, our plant e-box. And now the only thing you have to do is use your imagination to use our product and use the power of nature literally. I thank you for your attention and hope to welcome you at the plinth for more information about our product. Thank you very much.
Good afternoon, my name's Christopher Turo. I am here with Hope Resources. We have a way of environmentally processing waste with zero emissions. Waste with regards to infrastructure is a huge problem. There is a lot of waste that ends up in landfill, goes to incineration, both of which are environmentally damaging. There's a huge emissions of CO2, of methane, of NOx, and other pollutants such as fines. It's expensive to deal with, and Hope Resources come up with a solution that not only reduces the expense of processing the waste, it removes the toxins, removes all the methanes from the environment. We are currently in the process of...
It doesn't matter if I have to stop and keep going because you'll just cut this. Yeah, okay, cool. So if I mumble, just knock it out.
The UK alone produces around 220 million tonnes a year, 53 million tonnes of which ends up in landfill. There's also a lot of incineration in the UK, which is highly polluting, and Hope Resources is looking to step away from that. The way in which we're looking to do that is through vacuum reforming. This is just a very simple schematic to understand exactly what happens. Put waste in, it becomes vacuum reformed, which means we're running at negative pressure. Nothing escapes from our process. We produce syngas, which is conditioned, filtered and cooled, and from syngas it is possible to produce a number of products which we'll come on to, but our primary focus initially is into hydrogen. Hydrogen, we believe, is the fuel of the future. This process in the production of syngas is zero emission, which is very important to understand. We are a waste to zero waste process. The outputs that we do get are syngas and ash, and it's very similar to a fly ash, like a gravel, a bit like pumice, and it can be used in road construction, concrete block manufacture as a bulking agent, making the production of blocks that are used for buildings a lot greener. The process itself sits within shipping containers generally to allow very simple implementation, very low civil engineering requirements. It's a modular system, meaning that we deal with modular systems that process around 3 tonnes of waste per hour, depending on what the mix is, and you can process approximately 25,000 tonnes of waste per year with one module. If you're looking to process more waste, you would simply put in another module. What we do not want to do is go to bigger and bigger units with higher and higher kind of civil engineering costs, and also you need to start looking at how you transport and the logistics of it. The waste that we process are any carbon-based waste, by the sense of plastics, rubbers, car tyres, mattresses, biomass, farm waste, medical waste. There is no need to segregate the waste before processing it with the Hope Resources vacuum reforming system. We are dual revenue generating, both from the kind of the gate fee that comes with the waste and the outputs, which can be hydrogen, clean fuels, ammonia, fertilisers. Obviously, waste, as I've mentioned, waste in the UK is very expensive to deal with. There are higher grades of waste that we would look to go after, which are in the medical sector, very expensive to process. There's a massive export market which we can tap into, and there are basically higher gate fees. So the kind of advantages of the Hope Resources process: we process unsegregated waste. We don't need to separate it in any way. You can mix plastics with biomass, with food wastes, tyres, GRP, paper and card. It's a significantly lower capex to implement. The relative cost to, for instance, an incinerator or general kind of a more generic gasification plant per tonne are significantly reduced. It's a modular system, which means it's very easy to kind of transport, requires simple civil engineering to set up, and projects can be scaled organically as the waste amount or the waste supply increases, additional units can be put in. It's approximately 10 months turnaround from start of project to project 100% operational. It's not necessary to run a project at 100% capacity, but it is, and it's possible to run it at 50%, but from an economical standpoint, running at 100% is obviously far more beneficial. It's also a much lower production cost than the technologies required for high pressure, high temperature vessels. We run slightly lower than gasification and incineration, which means we don't need such expensive pieces of equipment.
And with what we can do with syngas, obviously we have our kind of preferred routes, which are primarily hydrogen, but also we can produce wax, kerothenes, gasolines. The shipping industry is a large target for us. They've just had their emissions limits reduced significantly, and we produce I'm not allowed to say it, but a close to very zero sulfur fuel, which is a lot cleaner and would fit within their limits. So that's our approach to how we can kind of great infrastructure challenges. Any questions?
Thank you very much. I'll kick off questions.
Yes.
You were talking there about outlets for the syngas. Have you tested demand for that, or have you got a solution here that for dealing with the waste, but nobody buying the gas?
Well, we have a number of options for what we do with the gas, and depending on what the client is after. For instance, the first project we'll probably look at producing liquid fuels. There's a ready market, there's a demanding market, and that would be our first port of call. What we can then do is demonstrate the production of hydrogen gas. The hydrogen economy is very much a chicken and egg scenario at the moment. People want the hydrogen, but it's expensive to produce. And people are looking at producing cars, but there's not the right hydrogen market. So as the hydrogen market grows, we will keep up to speed with that demand, as it were.
Our mission as a company is to reconnect people with nature. The project we put in Wimbledon last year demonstrates how we do that. And a couple of other examples. We're changing spaces from this to this. We're really reconnecting people with nature by introducing green infrastructure into urban environments. By doing that, we can do all sorts of things with biodiversity. We can do all sorts of things with air quality. But air quality that I want to talk to you about in a second. Just the look and feel as well. That whole enrichment of spaces has a real benefit for people. It works indoors as well. So this is a departure gate in Heathrow Airport. We convert it into this. So that's great and wonderful. And what we can do in terms of converting spaces and bringing green infrastructure into cities is very, very necessary. Our cities are very bereft of green infrastructure. But there's something we want to do to take it further. So we've been doing this for 12 years or so with these sort of high-profile projects. What we've done in the last 2 years is develop a new living wall system. And I want to introduce you to a term called phytoremediation. Phytoremediation is about biological filtration systems. So we're talking about moving on from mechanical filtration and technical filtration back into phytoremediation, which is the power of nature, the power of plants, and what plants can do for us, or what nature can do for us. People start to get a little bit iffy about phytoremediation. They start to think, well, what can plants do for us? What does nature do for us, apart from providing clean air, fresh water, food, all those sorts of things? The power of plants and the power of nature is an extraordinary thing. When you go outside and breathe air, you are breathing air that's been non-mechanically managed, it's been non-mechanically filtrated. When you come inside here, all the air is coming through a ducting system, it's coming through filtration systems. We can recreate that. We can recreate those mechanical filtration systems. What we've created is an active airflow living wall system. So what you see here is rather than a passive living wall or a passive piece of green infrastructure that does absolutely wonderfully well, from an air pollution point of view, it can only deal with the air that reaches it. With an active airflow living wall system, we can actually draw the air through the roots of the plants. In that root zone of the plants, what happens is you get small rootlets that appear on those roots. There are then mitochondria, which are small creatures that are living in symbiosis with those plants that can then translocate the toxins that come in, so particularly the benzenes, some of the oils and nitrogen dioxides. We can translocate those and change them into nitrogen for plant food and releasing the oxygen. So we're seeing basically a biofiltration system. The system is shown here. You can see the air is drawn through. The fan is sitting in a plenum chamber. Within that plenum chamber, we can then direct and divert that air by throwing it to locations where we want it to do some good. Bus stops, clean air shelters outside, internal office spaces, all these sorts of things. We've tested it in University College London last year. We put a petrol generator in there. We created a very, very toxic environment. This is the system under test. The photo on the right shows you the plenum chamber at the back. We're drawing air into that plenum chamber through the roots of the plants. And the type of results that we're getting are 97% of nitrogen dioxide that passes through the system is captured by the system. From particulate matter, it's again in the 90%. We've tested it in the same way as you'd test any air filtration system. So the same way as a Dyson air filter would be tested, that's how we've tested this system. The system unoptimized comes out with an efficiency rating of 65%. A Dyson air filter is 64%. So the power of plants and the power of biology is quite extraordinary. Some of the locations we want to put this into, internal office spaces. You can clean an office space, you do not need a ventilation system in there. On the top right, we want to have areas where we can create clean air zones. We want to protect people. The rate of heart attacks is going up whenever the air pollution is poor. We want to be able to reverse that by providing clean air shelters. Ventilation shafts. Can we clean the air before it goes into buildings or before it goes into the underground station? In terms of return on investment, we know that from the data that we collected within UCL, that the cost to benefit ratio based on DEFRA studies on air pollution is 250% in areas of high density population. We believe a combination of biology and technology is what will help us to have sustainable urban landscapes. Thank you.
Thank you very much.
Thank you very much. Thanks for inviting Arc Biodiversity and Climate. We're pleased and surprised that you've invited us because ours is not a thing. It's a method. It's not a product. It's a way of thinking, and it's designed to optimize the whole of the built infrastructure for ecological functionality and for resilience for people and wildlife. And so we call this method Shaping Better Places, and it's 3 simple decisions, and it's no more or less than a to-do list. Do 1 thing, things get better. Do 2 things, things get very much better. Do 3 things, everything changes. Horizons broaden, opportunities pile up one on another, and that's exactly what is required. If we're going to get anywhere near the requirements upon us, we have to have this systemic change across all of our built infrastructure. So what does this mean? What do you have to do? The first decision is to deliberately go about building fully functioning ecosystems in the built environment. We can make the built places we make for us function fully as ecosystems for the natural world, in the places that we inhabit. Why wouldn't we do that? It doesn't mean your building is going to fall down. It doesn't mean your loft is going to be full of bats. It might be. It doesn't have to be. It doesn't mean your garden is going to be full of nettles. You don't need that stuff. We can be sophisticated about making the built environment functional for wildlife. Fully functional, not expedient, not purely decorative, fully functioning ecosystems in the built environment. Once you decide that, all sorts of other things happen. That's the first decision. The second decision, having decided that, is to look at the unit, the quantum of your development or infrastructure. There might be a single wall on a building in a plot, a single plot in a neighborhood. It doesn't really matter. Start with the quantum of development and look from top to bottom at opportunities to intervene. You don't have to do everything everywhere. Just change certain things where you can. Could be a window box, could be a street planter. A street planter can be a fully functioning ecosystem if you want it to be. So look for these punctuated interventions in the built environment from top to bottom. That 200 meters of our domain that we build is exactly the same as the natural world. High-level migrations aside, The daily operation of the natural world is within that scale. Why wouldn't it be? We're medium-sized wildlife building habitats very badly for ourselves. The natural world responds in the same way. We're looking for punctuated interventions. And the third and critical thing is to pattern repeat. Once you have built this cluster of ecological intervention, a planter and a window box, a roof, a wall, a piece of greenery, fully optimized for ecology, you repeat at a meaningful distance. 100 meters, 150 meters, 300 meters, 500 meters, by which I mean that the wildlife you build up in one place will find the next. And the space in between becomes enriched and enlivened without you having to do anything. You can come back to those spaces, fine, brilliant, absolutely fantastic. But you can patch your way through your built environment, building up spikes of ecological density that communicate. Your green roof talks to the landscaping below at this point. They are saying the same things. You're providing life cycle resources, breeding, feeding, hibernation, overwintering, pupating, display, all of the requirements of wildlife built in to the infrastructure we create. It has asset resilience, it has psychological resilience, it is necessary work. And we can leapfrog our way. It may be within your red line still, but it may not be. The next thing in this zone of intervention may be a school or a church or an abandoned piece of public land, and you as an infrastructure delivery organization will be communicating with a new audience beyond your traditional stakeholders by taking this approach. Your legacy, in effect, ripples out beyond you. Pattern repeat is crucial. And by doing these things, we're in the last minute, your built environment outperforms in terms of its environmental qualities. You're faster through the planning system. No rafts of awful planning conditions because your application wasn't good enough to start with. You're building conversations with the community that hosts you and your infrastructure. And you're increasing investor confidence because they are going to be asking these questions. How are you going to do this? How are you going to deliver these resilience requirements? It can be done by following those 3 steps. Thank you very much.
Okay, thank you very much.
Can I get some water?
Sure. I'm sure there's more to it than just those 3 questions. Otherwise, you've given away all your IP in the last 4 minutes.
Source.
So can you just tell us briefly, what's your target market? Who is it you're trying to sell this to? And what is it they benefit from engaging with you beyond those 3 questions?
Okay. It's literally everybody, but let's just focus on 2 very interesting and very similar markets. Housing association providers, we are talking to with exactly this conversation, and investment houses. They have the same business model. They need that asset, which they will own forever, to have no voids. They need tenant retention, and then with reliable rental income. So for those 2 markets, by fully optimizing the estate they have for biodiversity, it has immediate gains in the way that their stakeholder community, their clients, their tenants actually like that place. So those 2 groups are very important to us, the investment house in particular, but the big civils, just being able to offer some kind of differentiation in the market by taking this approach. It's incredibly efficient. When we talk to the private sector with a development conversation, we are constantly saying, you can develop that space. That is the developable space. You have given it away for spurious ecological reasons. Wildlife doesn't want this thing you have given it because it's useless. Let's put something useful in there and embed ecological gain across the whole of the estate. So fudged the answer to your question. It is literally everybody, but within that there are some clear clients we're interested in.
Hello, my name's Niall. I'm the Business Development Manager for Scottscape. I'm here today to talk about a new product which we've had in development, and this is our product called Living Pillar. So Living Pillar came as a thought at the end of 2017, and we brought our first pilot scheme to life on Ebury Street on May of last year. Now this was in conjunction with Westminster Council and with Grosvenor Estates. So the structure itself is designed to wrap around any lighting column, or any column. It's solar powered, which charges a battery, which activates a pump hidden in the bespoke reservoir tank, which pumps the water up, and this operates in a closed loop system. We currently are operating at a price of about £2,500, but with future developments, we're hoping to bring that below the £2,000 mark. Our biggest issue today is maintenance. We have to fill these irrigation tanks every 7 to 10 days. But when we think about other green infrastructure at street level, the hanging basket gets irrigated twice per day during the summer months, and 80% of that water does end up on the floor. We are every 7 to 10 days, and in the winter months we're aiming at about 20 days. As we develop this product even further, we're looking at soil sensors which will automatically irrigate the plants as and when required. We do have a maintenance cost approximately £25 per month per pillar. Given volume discount on any given street, we would aim to reduce, but hugely we would want to train up local council maintenance teams that they can add water into these irrigation tanks so they can be self-monitoring. So when we brought this system to development, we employed Greenwich University to carry out lots of the technical studies, so structure loading, wind loading, air pollution, and to water consumption. Now, during that period, we have now made several changes to the overall design of the product itself. One slight change will be a conical shaped reservoir tank. That's going to collect any rainfall which may hit the leaves and is recirculated back into the system. Now, currently today, it takes us approximately 1 day to install one pillar. That allows us to get to site, construct a scaffold, install and deconstruct. Everything is done off a tower scaffold, so the disruption to street level is absolute minimum. So why would we have this as a concept? We encourage everyone, every developer, every town planner is to have purpose in their planting. I think me and Ian probably read the same book, is having purpose to planting. So you could create wildlife corridors, biodiversity corridors. You could link Park A with Park B, create bee lines across city centres. If you've done a long journey today on a motorway, what would you expect to find? A service station. So when you include the correct type of plants into these structures, we create service stations for insects, so they have a little habitat to link on to the next bigger green infrastructure area. When it came to air pollution, we use lots of the plants as studied by Dr. Ross Cameron of Sheffield University for trapping particulates. We have included those into certain of those structures, and we have noticed a positive effect on the mitigation of air pollution. We can also run all of these plants through programs such as iTrees. That will give us a financial highlight to the value of each one of these. Now, don't take this out of context. We are not saying that one pillar on one street is going to revolutionize that entire street. The same as one tree could not revolutionize one street. It's the collective effort. It's about bringing more greenery down at street level where it can become beneficial to the people who inhabit those spaces. And even when we speak about the financial value, well, there are other values to be gained, and that could be from the sense of well-being within people. It's wayfinding and place-making. We've also considered the idea of having augmented reality codes wrapped on the irrigation tank. So you as Joe Public can go to one of our pillars, scan the augmented reality code with your phone, and within that it will show you why it was there, about the plant. So it'll give a good educational infographic on how and why it was done. But this can also be seen as an advertising space that maybe town councils could take revenue for having advertising installed within this augmented reality. And one thing we have noticed, we've installed one of these outside the head of landscaping offices for Grosvenor Estates, and just on a sideline, as they were looking out their office one day, it became a noticeable trend. As people walked up and down Ebury Street, our pilot scheme, people stopped. They looked, they smiled, and they were happy. So my time is done, and I'll welcome any questions. Thank you.
Good afternoon to you all. My name is Dill Robinson, and I'm here on behalf of ACCO to pitch to you our patent-pending blue roof attenuation system. With the global climate change emergency we now face, storms Kira, Dennis and George being very recent examples, it has never been more important not just to look at the ways we can mitigate the change, but to act positively to minimise the impact on our environment. In urban environments where space is at a premium, blue-green roofs offer a way to meet these climate change objectives by reducing urban heat island, improving flood resilience, improving air quality, sustainability, and offering amenity benefits. Blue roofs are a recent innovation to tackling urban flooding, particularly where other more established methods are impractical. However, there are no accepted standards for the design of blue roofs. As such, engineers are expected to solve a design dilemma by interpreting existing standards and practices. This invariably leads to compromise, and by extending the logic, increased risk. Increased risk is something that engineers, architects and clients want to avoid wherever possible. In the UK, blue roofs as a concept are little more than 10 years old and are generally offered by roofing companies, yet their function is one that needs an understanding of their role in a wider sustainable drainage context. The reality is that the drainage function of a flat roof and a blue roof are not compatible. One requires the roof to drain very quickly in extreme events, and the other very slowly. This is a real design challenge. Until now, engineers and manufacturers have tried to offer a single solution that aims to accommodate both extremes. Such an approach will require an acceptance of increased risk. A failed blue roof will not lead to a leak, but to a flood. For this reason, there is a reluctance to site such systems under habitable and sensitive buildings. Naturally, this limits the extent to which such systems can contribute towards the mitigation of climate change. The ACO Blue Roof Attenuation System overcomes these issues by treating the competing design requirements as separate but linked solutions. The ACO Blue Roof Attenuation System elevates the blue roof off the roof via a structural drainage sheet to create an independent attenuation tank that does not compromise the function or design of the flat roof. The double waterproofing reduces risk and does not affect the normal roofing warranties, giving the engineer and client peace of mind. In an unforeseen eventuality that the blue roof tank is completely full, when an extremely intense downpour occurs, rainfall can bypass the attenuation control by overflowing the sides of the tank and flowing unrestricted underneath the blue roof tank to the roof outlets as required by the British standard. Until now, blue roof systems relied on a single waterproofing membrane to act as a building waterproofing and the attenuation liner. This is very problematic as the roof has numerous penetrations, roof outlets, vents, flues, fixings through the roof itself from plant equipment, and therefore more opportunity to leak than a conventional attenuation tank, which has no penetrations through the base. The consequence of failure will generally be far more severe for a blue roof attenuation system than a conventional below ground one. As the top of the tank is open, it can capture rainfall and attenuate the rainfall to meet planning conditions. But in an unforeseen eventuality, the tank can be bypassed and drained quickly to the required standards. The benefits of this unique design solution are numerous. The design dilemma is resolved without the need to rewrite existing standards. All flat roof drainage constructions can be accommodated, whether they're warm, inverted or podium decks. Design responsibility is clearly defined and not compromised. Hydraulic calculations do not need to differ. The roof waterproof membrane is not compromised, so there is no change in construction industry warranties, and a wider range of building applications are achievable, residential and retrofit all offering opportunities. ACO have thought laterally to resolve the design conundrum that has become urgent as blue roofs move into the design mainstream. The concept is simplicity itself. I'd just like to conclude our pitch with the words of the world's greatest natural philosopher, Sir Isaac Newton. Nature is pleased with simplicity, and nature is no dummy. Thank you.
So that concludes the pitching phase. So thank you to all 6 of our presenters for their very informative presentations. The 4 of us as judges are now going to deliberate for, I think, about 10 minutes. So I'd encourage you to hang around and wait, and we will, I hope, come up with a clear winner out of here. But you've given us a challenge, I have to say. So thank you all very much. Please bear with us. Okay, ladies and gentlemen, if I can just call order. I just want to thank again all 6 participants in this process. Thank you for taking the time to put your presentations together, taking the time to tell us all about your innovations. You did give us a real hard challenge. How do you compare 6 very different applications to solve some of our environmental challenges? But as judges, we have come to a conclusion, as tough as it was, and the winner of the critical infrastructure big innovation pitch is Hope Resources. What particularly impressed us with Hope, do please come up. What really particularly impressed us there was the ease of implementation of a new solution, its scalability, and the fact it gives a productive use to waste at end of life, and is a cheaper solution than the current alternatives. So congratulations.